Okay, in this tutorial we're looking at section 6.2 on the chain rule. Okay, so this is how we differentiate composite functions. So remember, our composite functions is when we've got a function within a function. Okay, so for example here we've got f of x equals g of h of x. So h of x is our function within g of x. Okay, so for our chain rule, if f of x equals g of h of x, then f dash of x equals h dash of x times g dash of h of x. Now it looks a little bit confusing, but once we get into some worked examples you'll see how it turns out. Okay, and that's our Newtonian notation. Okay, our Leibniz notation is saying that dy dx equals dy du times du dx. Okay, and we probably get the idea of our chain rule here because we have this link, okay, between our du's here. Okay, so we'll get into some worked examples, and I've got two different methods to show you for this, probably the long way and probably the slightly easier way. Okay, so we'll have a look here at this worked example. So we've got if f of x equals x cubed plus 2x squared, take x to the negative 2 all to the power of negative 7, find f dash of x. Okay, so the first thing that we do here, okay, is we do a substitution and we say let u equal whatever's inside the brackets. X cubed take 2x squared take x to the negative 2. Okay, and then what we do is we replace f of x with y. So now we say that we've got some function y now is equal to u to the power of negative 7. Okay, now we find our derivative of y with respect to u. So we say dy du, our derivative of y with respect to u. Remember, original power comes down the front, so it's negative 7. U, take away 1, makes it to the power of negative 8. Right, and we also need to find du dx. Okay, so the derivative of u, this function up here, with respect to x. So again, we bring our power down the front, so we get 3x squared take 4x, okay, plus 2x to the negative 3. Okay, because we have to bring our old power down, double negative is going to get us our positive, okay, and subtract one off will give us our negative 3. Now remember, dy dx is equal to dy du times du dx, okay, because they will cancel out to give us our dy du. So we need our dy du. Now what we usually do though is actually put this one at the front, okay, because we're going to have dy dx equaling negative 7 times 3x squared take 4x take 2x to the negative 3 times by our dy du, okay, which is our, we've already put our negative 7 in, okay, and now we need our u to the power of negative 8. Okay, and then we sub our u back in, so we get dy dx equaling negative 7 outside of 3x squared take 4x take 2x to the negative 3 times by our x cubed plus 2x squared take x to the negative 2 to the power of negative 8 now. Okay, because we have negative 8 there. And we've got our derivative. If you wanted to, you could multiply the negative 7 through here. Okay, but it's not going to make a huge amount of difference, so I'm not going to worry about that. Okay, method 2. Okay, now this is really utilising this here. Okay, so we're saying that f dash of x equals h dash of x g dash of h of x. Okay, so what we do is we go, okay, well let's bring our power down the front because we know we have to do that. So we say, well, f dash of x equals, oh, and sorry, I just remembered here, we changed our terminology here to dy dx, but the question actually wanted f dash of x, so we should actually, at that last step, put f dash of x again. So I just need to fix that up. So sorry, we bring our power down the front and say that we have negative 7. Okay, and then we times it by the derivative of what's inside here. So what our derivative is our 3x squared plus 4x, okay, plus our 2x to the power of negative 3, like we found before. Okay, and then it's the derivative of all this. So basically all that means is now we've got to change our power down by 1 and leave what we had in there originally. So we've got x cubed plus 2x squared, take x to the negative 2 to the power of negative 8. And we're done. So I've done it basically all this work in more or less one step. Okay, so what we've done is we've brought our power down, taken the derivative of what's in our brackets out the front as well, and reduced our power by 1. We've got now our answer. So we'll keep moving on. We've got another worked example to look at. Okay, so this one is our worked example 2. Okay, we need to use the chain rule to find our derivative here. Okay, so the first thing to realise is this is cos squared of e to the x. Okay, so that means it's cos of e to the x times cos of e to the x. Okay, so I'm going to start by writing it as y equals cos of e to the x squared. Okay, so now we can do our step of let u equal cos of e to the x. Okay, so then we have y equals u squared. So then we'll do our dy du equals 2u. Okay, now du dx is a little bit trickier here. I'll swap colours and we'll just do it down the side here. Because really we've got, at the moment now, we've got u equals cos of e to the x. Now we've got a function within a function again. So really what we should be doing is saying, well, let v equal e to the x. So now we have u equals cos of v. Okay, is what we should be looking at there. Okay, so then we can do dv dx. Okay, is going to equal just e to the x. Derivative of e to the x is e to the x. And then du dv. Okay, well, derivative of cos is negative sine, so that's going to make it negative sine of v. Okay, and remember we want du dx. Okay, so du dx is going to equal du on dv times dv on dx. Okay, so our du dv is our negative sine of v. Okay, times our dv dx, which is e to the x. So I'm just going to put that first and say we've got negative e to the x sine of v, and we need to sub that back in now, and so we've got our du dx equals our negative e to the x sine of e to the x. Okay, so now we've got our du dx as well. So I'll just put that over here in our blue, du dx. Okay, equals our minus e to the x sine of e to the x. Okay, so now we can put everything together, because again, dy dx equals dy du times du dx. So our dy du is our 2u. Okay, and our du dx is all this, so I'm going to bring my 2 from up here into here and say we've got negative 2e to the x sine e to the x. Okay, times our du dx, which was, we just have our u left over. Okay, so we'll keep moving. We can put our u back in now. So we've got negative 2 e to the x sine of e to the x. Our u was equal to cos of e to the x. Okay. And we're done. Okay, and we're finished for that one. Okay, so our other method, okay, look, it doesn't make it a whole lot nicer, our other method, okay, but there is a different way of thinking about this too, okay, which, what I like to do is we say, well, again, we've got our, we say that f of x equals g of h of x, okay, So what we do is actually list down what g of x is. So say, well, g of x is our cos of x squared, or cos squared of x, and our h of x is equal to our e to the x. Okay, is equal to our e to the x. So then, what we do is we can say, well, h dash of x is our e to the x, and when we want to find our g of x, well, again, that's where we need to do really another function again. So we'll just wait a second and go, well, I isn't really a great one to use. Might go to, say, n. So what we're going to say is really that for here, we're saying, well, g of x is really equal to n of, I don't know, let's say m of x. Okay, where n of x is equal to x squared, okay, and m of x is equal to cos of x. Right, well then we say n dash of x is equal to 2x, and m dash of x is equal to negative sine of x. Okay, so that means that our g dash of x, okay, is going to be our, we've got to bring these together. So we've got negative 2 sine of x. Okay, so our g dash of x minus 2 sine of x. Okay, so then we can bring everything together again, okay, for our function. So we need our h dash of x out the front. So our f dash of x equals h dash of x, g dash of our h of x. So f dash of x, our h dash was our e to the x, our g dash was this, so we can say we've got our negative 2e to the x sine e to the x. Our g dash, okay, so then we're just going to finish it off with our cos of e to the x. Okay, to finish it off, and we're done. Okay, this way for this one, because it's we kind of got the double chain rule that we need to do. This method is probably a bit easier, but just the way that I've set this up is the way that I'll set things up for our product rule and our quotient rule later on. So sometimes you might find that this is a better way to go. Okay, it just depends. In the textbook, they kind of skip through this second step and they kind of just do it all in one step. Okay, but you've got to understand that it's a function within a function and what that's going to actually mean for the derivative, which I don't really talk about too much in that worked example. So that's all we have for this section. So look, the chain rule isn't horrible. You will have seen it last year in year 11 work, so hopefully it's more revision than anything brand new.